Hello guys, in this video, we will learn about the Astable Multivibrator using the IC555. Aim: to perform an Astable Multivibrator using 555 timer, to observe and plot the output voltage, to observe and plot the capacitance voltage, calculate the time the output is high, the time the output is low, total time period, frequency, and percent duty cycle. Theory 1 of the most versatile linear ICS is the 555 times. It was first introduced in early 1970 by Signetic Corporation, giving the name as SE/NE555 timer. The 555 is a monolithic timing circuit that can produce highly stable time delays or oscillation. The timer basically operates in one of the two modes, either as monostable or as an astable multivibrator. A astable multivibrator, often called a free-running multivibrator, is a rectangular wave-generating circuit. Unlike the monostable multivibrator, this circuit does not require any external triggering to change the state of the output, hence the name free-running. However, the time during which the output is either high or low is determined by the two resistors and a capacitor which are externally connected to the 555 timer. 555-pin configuration. The 555 IC is available as an 8-pin metal can as given below. Pin 1, grounded terminal. All the voltages are measured WRT this terminal. Pin 2, trigger terminal. This pin is an inverting input to a comparator that is responsible for transition of flip-flop from set to reset. The output of the timer depends on the amplitude of the external trigger pulse applied to this pin. Pin 3. Output terminal. Output of the timer is available at this pin. There are two ways in which a load can be connected to the output terminal, either between pin 3 and ground pin or between pin 3 and supply pin. Pin 4. Reset terminal. To disable or reset the timer. A negative pulse is applied to this pin, due to which it is referred to as reset terminal. When this pin is not to be used, it should be connected to plus VCC to avoid any possibility of false triggering. Pin 5. Control voltage terminal. The function of this terminal is to control the threshold and trigger levels. Thus, either the external voltage or APOT connected to this pin determines the pulse width of the output waveform. The external voltage applied to this pin can also be used to modulate the output waveform. When this pin is not used, it should be connected to ground through a 0.01 microfarad to avoid any noise problem. Pin 6. Threshold terminal. This is the non-inverting input terminal of comparator 1, which compares the voltage applied to this terminal with a reference voltage of plus 2/3 VCC. The amplitude of the voltage applied to this terminal is responsible for the set state of flip-flop. Pin 7. Discharge terminal. This pin is connected internally to the collector of transistor, and mostly a capacitor is discharge terminal because when transistor saturates, capacitor discharges through the transistor. When the transistor is cut off, the capacitor charges at a rate determined by external resistor and capacitor. Pin 8. Supply terminal. A supply voltage of plus 5 volts to plus 18 volts is applied to this terminal WRT to ground pin. The 555 timer as an astable multivibrator. The schematic of a 555 timer in astable mode of operation is shown in Figure 2. The circuit details are given below. Pin 1 is grounded, pins 4 and 8 are shorted, and then tied to supply plus VCC. Output is taken from pin 3. Pin 2 and pin 6 are shorted and then connected to ground through a capacitor. Pin 7 is connected to ground through a resistor RA, and between pins 6 and 7, a resistor RB is connected. At pin 5, either a bypass capacitor of 0.01 microfarad is connected, or modulation input is applied. Astable operation. According to Figure 3, initially when output is high, capacitor C starts charging toward VCC through RA and RB. However, as soon as voltage across the capacitor equals 2/3 VCC, comparator 1 triggers the flip-flop and the output switches low. Now capacitor C stars discharging through RB and transistor Q1. When the voltage across C equals 1/3 VCC, comparator 2's output triggers the flip-flop and the output goes high. Then the cycle repeats. The output voltage and capacitor voltage are shown in figure B. As shown in this figure, the capacitor is periodically charged and discharged between 2/3 VCC and 1/3 VCC, respectively. The time during which the capacitor charged from 1/3 VCC to 2/3 VCC is equal to the time the output is high and is given by TC equals 0.69, open parenthesis RA plus RB close parenthesis times C, where RA and RB are in ohms and C is in farads. Similarly, the time during which the capacitor discharges from 2/3 VCC to 1/3 VCC is equal to the time the output is low and is given by TD equals 0.69 RB times C. Thus, the total period of output waveform is T equals TC plus TD equals 0.69 RA plus 2RB times C. Frequency of oscillation, FO equals 1/T equals 1.45 divided by open parenthesis RA plus 2 RB close parenthesis times C. Duty cycle. The duty cycle is the ratio of the time Tc during which the output is high to the total time period T. It is generally expressed as a percentage% duty cycle equals T sub C over T times 100 times open parenthesis R A plus RB, close parenthesis over open parenthesis R, A plus 2, RB, close parenthesis times 100. Applications of Astable Multivibrator. The Astable Multivibrator is used as square wave oscillator. It is also used as free running ramp generator. It is used as pulse position modulator. It is also used for Schmitt trigger using 555 timer. Procedure. Connect the components as mentioned below. L1 to L12, L14 to L12, L16 to L12, L4 to L9, L8 to L9, L10 to L19, L3 to L17, L11 to L13, L7 to L19, L6 to L13, L2 to L13, L5 to L15, L18 to L9. For example, click on 1 and then drag to 12 and so on. Click on Check Connection button to check the connections. If connected wrong, click on the wrong connection. Else click on Delete All Connection button to erase all the connections. Initially set RA equals 3.3 kiloohms, RB equals 6.8 kiloohms, C equals 0.1 microfarads, VCC equals 5 volts. Click on Calculate button. Now note the output voltage. Click on Plot button to plot output voltage, capacitance voltage. Click on Clear button to clear the data. Repeat the experiment for another set of resistance value. Set the resistance, Ra value, 1 kiloohm to 10 kiloohms. Set the resistance, Rb value, 1 kiloohm to 10 kiloohms. Set the capacitance, C value, 0.1 microfarad to 10 microfarads. Set supply voltage, VCC.